Okay, you can continue. I don't. Okay. Josh, I'm still waiting for answers from you, you know. You didn't send me any answers yet. Wait, Josh, you sent me number 6. When? When was that? No, what you say in your handwriting is in neat on the screen and it's better than mine. What the heck? Like 15.5 hours ago. Uh-huh. Sorry. Well, resend it, please, because I did not see that. Josh, I am not seeing it. We need to resend it. Oh, wait, look, it's right there. Oh, I see it, I see it, I see it. That's correct. What happened to number 7? Sorry. I wonder if I could do number 6 right to the side here. Oh, let's try it in. What's number 6? Well, that was the one with cause. Let me try something. While he does that to the side there, let me do number 6. Who is joining my name? Why is there a black line there? I don't know, anyways. Okay, I'm gonna just wait for him.
Is that the answer?
What? This?
Red, yeah.
Wait, who asking me that?
Me, Jules.
Well, yeah, he's doing right so far. Why, you think something wrong with it?
No, I was just asking. I was.
Okay.
Okay, I think that's about it. I I I don't know if I skipped a few steps, but this is the most detailed I could make the flow of my thoughts. So
Okay, this is correct. So this is the question here. You're required to integrate 4 cos x plus 2 sin x with respect to x, and you told that the upper limit is pi on 3, lower limit is 2. So the first thing you want to do, so just temporarily, ignore all these things, ignore the limits, whatever. We just integrating this expression here. 4 cos x plus 2 sin x. I apply my rules of integration. I am going to get 4 sin x minus 2 cos x. Anybody needs me to go through that? Please let me know. Limit, pi on 3, 0. All you're doing now, substituting it into this expression. So wherever you see x, you're going to replace it with pi on 3. That's what he has here in this first bracket. Then in the second bracket, you replace x with 0. Simplify, you're going to get this. Anybody needs me to go through that slowly?
Yes, please.
Yes? Somebody say yes?
Yes. Yes.
Okay. Okay. Like you want me to write it out?
Yes, please.
Okay. This is taking a bit long. Wait, no, not a bit. This is taking way longer than expected. That's cool though. What was he saying here? Somebody please tell me.
I think it was cosine of 3 theta.
No, the one before.
Oh, sorry. That was 4 cosine x plus 2 sine x.
Yeah. Plus 2, oh my gosh. Anyways, plus 2 sine x with respect to x. So the first thing you want to do for definite integration, is to integrate this expression here, right? Why is there this thing here? What is, anyways, I don't. We're integrating this, right? Using my rules. Do you need me to go through this slowly, like how exactly I'm supposed to integrate this expression in? Or you're fine with that?
Slowly, please.
Slowly, please.
Okay. My rules of integration. The first thing you should notice, see this addition sign. It indicates that I have a sum, right? So what am I talking about? There's a rule that says if I have to integrate an expression that has sums and differences in it, so you see an addition sign, you see a subtraction sign, you see both of them, that rule applies, right? And what that rule basically says is that if you see sums and differences, same rule of integration that you're using, you just have to integrate each term, right? So if I said I want to find the integral of 4 cos x plus 2 sin x, it's the same as saying I want to find the integral of 4 cos x plus the integral of 2 sin x. So this is me ignoring the limits and everything for now. All I'm focusing on is integrating this expression right here. So if I want to find the integral of 4 cos x plus 2 sin x, according to my rule, that's the same as saying the integral of this term right here, 4 cos x, plus the integral of the second one, 2 sin x. But this is a problem. Yes, I have a rule that helps me to integrate trig function. But the rule, if you look at the rule, right, there isn't any number in front of it. Let me just show you real quick. Let me just show you one of them. The rule says the integral. I'm doing the one for sine, right? Sine ax plus c is going to be equal to 1, well, minus 1a cos angle 360. If you look at this rule, there is no number in front of this here. Well, let me not show you. Okay. Looking at this. When I'm integrating the trig function, yes, I have a rule for how to integrate trig functions. But in my rule, there's no number in front of the trig function. Here, what I have right now, there are numbers in front of it. So you can't really work with that, right? That's why we have another rule, right? In this one in red. This is a rule that we know. If I'm required to integrate a by f of x, so a is a number, right? That's the same as saying a by the integral of f of x. Therefore, according to this rule, see these two things here? They can be rewritten as 4 by the integral of cos x plus 2 by the integral of sin x. That's just me taking this number in front and putting it outside. So saying the integral of 4 cos x is the same as saying 4 multiplied by the integral of cos x. Now, I have it in a form that I can use. I have my trig function here, and I know a rule to help me integrate the trig function. So for the cosine function, it says the integral of cosine ax plus b is equal to 1 on a sine ax plus b. When I integrate this, I'm going to get plus 2. The integral of sine x is going to be minus cos x. And I simplify from there. Sorry, I need water. So 2 cos x. Then I bring back to my limit, upper limit pi on 3, lower limit 0. Are you good with that?
Yeah, a bit, yeah.
Somebody else had asked me to go through it. Look, somebody else is talking to me. Okay. Do you need me to continue or are you good?
I'm okay.
Alright. Who answered me just now? 2.
Yes, Jules.
Okay, next one. Cos 3 theta. Upper limit pi and 3. Was it? Was it pi and 3? It was pi and 3. Lower limit pi on 6. When you integrated this right here, cos 3 theta, what did you get? Anybody, what'd you get?
1/3 sine 3 theta.
103 sine 3 theta. Anybody does not understand how you got this? Going once, going twice, 3 times. Nobody. Okay, well, I'm moving on, right? Since nobody tell me anything about this. Right. All you're doing now, substituting the upper limit and the lower limit into this expression right here. That's all you're doing, subtracting. It's simple, right? So a third sine 3 theta. But instead of putting theta, I would replace it with my upper limit first, pi on 3. So that's my first bracket. And if you would compare this to the definite integration formula that I showed you, this would be considered f of b. Then f of a would be a third sine 3. Instead of putting theta, I'll replace it with the lower limit now, which is pi on 6. From here, it's just simplifying, right? So what would happen? This 3 would cancel with this 3. Sine of a third sine. Okay, let me not add. Okay. Yeah, this will take a while. This would reduce to sine pi 2. And when I simplify and all that, I am going to get minus a third. Everybody good with that? Because this right here, sine of pi is 0. 0 by a third is 0. Sine of pi on 2 is 1. And 1 by minus a third is going to get me minus a third. This right here is my final answer. Is everybody good with that? Yes? No? Is somebody talk?
What's the final answer?
Minus a third. Let me write it. Minus a third. This is the answer. Can I clear this now?
I just want to ask you a question. If you don't have pi on your computer, on your computer, on your calculator, could you use 3.14 and that'll be fine?
If you can use 3 pi on 4.
No, if you don't have like pi itself, you know, pi on the calculator.
It's far more likely that it's there on your calculator, but you don't see it either because it's not a primary function. It could be a secondary function, on your calculator assigned to one of the buttons. If your calculator doesn't have pi, you probably don't want to be bringing that into an AdMax exam. In addition, I mean, everything she's done can be worked out by hand. So, I mean, it's not the end of the world. If you know a unit circle, you would know sine of pi is 0.
Okay, thanks.
Yeah, no problem. It's possible to maybe it faded out on your calculator from repeated use or something, but it should be there. Try playing around with the buttons until you find it.
Even if your calculator didn't have the pi function in it, which is highly unlikely, it like he said, probably faded, or you're probably just not seeing it, but it should be there. See these like sine of pi on 2, it can be calculated by hand, like especially if you know like the sine curve. Let me use blue. You know the sine curve looks like this. If this is y, this is x. Sine curve looks like that, right? So continuing, it cuts the axis here at pi. So sine, if this is a sine graph, then sine of pi is 0. So yeah, even if, like I was saying, like he was saying, if you don't have pi, the pi function on your calculator, these right here, these functions, sine of pi on 2, they can be calculated manually. Once you know about the graphs and like unit circle and all that, we should be good to go. Last question. Makes sense. Okay. Last one in this section. Just finish that out for me. Let me know what you get. That's not always the case. Okay, let's do this one. Upper limit 3, lower limit 1. 1. You need to integrate 2 on x squared minus 3 plus 2x cubed with respect to x, of course. See the minute you see something like this, like 2 on x squared, you know, you kind of integrate that. Why? You need it in the form ax to the n. So it's important for you to remember the basics. So the basics of integration, it must be in this form in order for you to apply the rules. The questions, they may seem a little more complex as we continue, but it's important for you to remember the basics, because that's how you do the questions, right? You build from the basics. Can't forget the basics and attempt to do a little more complex questions. You'll be confused. Oh, you probably get it wrong. You need to remember the basics, right? It doesn't matter how complex a question looks, just remember your basics. You know, you cannot integrate unless it's in this form, ax to the n. Don't forget that. 2 on x squared, that is not in this form. What does that mean? I need to get this, I need to rewrite this into this form. How can I do that? Well, based on my laws of indices, I know that 2 on x squared is the same as writing 2 by x to the minus 2. And just in case anybody who doesn't know or you don't remember, there's a rule from the laws of indices. So let me just represent it by, let me use x. No, let me use e. Okay, let me just use the a. So there's a rule that states 1 on a to the n. A is my base, n is the power. If I see a term written in this form, this is the same as saying a, still my base, but now the power is negative. So a to the minus n. This is a law that you learn when you're doing indices, right? 2 on x squared is the same as saying 2 by x to the minus 2. Look at this rule. Let me just do 1 on x squared is the same as x to the minus 2. That's just following my rule, right? Then I would put the 2x cubed after, and then the minus 2. I mean, you don't have to, but to me, it just looks neater this way, right? So this is the expression that I would be integrating because each term is now in this form, ax to the n. Each term is now in a form that I can integrate. So now I can apply my rules and integrate this expression right here. Using the rules, basic rule of integration. Can anybody tell me what I would get when I integrate this expression right here? This right here. Mm-hmm. Okay. Everybody just disappeared on me. Mm-hmm. Everything. Not. Oh, see that. Mm-hmm. Everybody good with this?
Curious, is it possible for us to, I just want to go over this with the coordinates and stuff that we did last class after like this session finished. There's something quickly I want to show you. I don't know if we could just use Zoom and I'll just turn on my camera to show you what I've written to be a bit clearer.
Okay, no problem. So I integrated. Of course, I don't leave it like this. This would simplify even more. So minus 2x to the minus 1 plus 2x to the 4 minus 3x, right? Substitute your values into here. First, you'll do the 3. So this will become minus 2. Let me write it out. Let me just write it out. Write it out. Because I know not everyone learns the new
Give us
thing.
a chance to screenshot.
Hmm?
I didn't get a chance to screenshot it.
Oh my, and there's no undo button. Does anybody?
Well, that's
Miss,
good. You can get some practice when you go home tonight.
well, Miss, it's recording, so that when he's watching the recording, he can like take a screenshot of before it, yeah.
Okay. This can be rewritten as, I could write it like this. Substitute my values, get your answer. So this is going to be equal to minus 213 plus a half, x in this case 3, right? So 3 to the, anyways, I'm just going to ignore that. 3, this is my first bracket. Things take so long to erase. I don't have the patience for this. Anyways, it could be like that.
So you inserted wherever the upper limit is, the value of the upper limit, wherever x is.
Yep. And then you do the same for the lower limit. So I just put a bracket here to show you this is the value that I substituted. Gosh, those dots. Okay. Anyways.
Sorry to interrupt. I may have to leave now, but it was nice learning from you today. Thanks a lot.
Okay, bye. By 1. When you simplify, you're gonna get 106 on 3. Of course, you do not skip all these steps like me. Simplify, get the value for this bracket. Simplify, get the value for this bracket. Then show them your final answer. So it's 106 on 3.
Do you leave it as 106 on 3 or do you divide it? You Bruce?
What? Do I divide
106 by 3, or do you leave it like that, or do you turn it to
this? Can't be
35.3?
this can't be simplified anymore. I mean,
Sorry, I wasn't here for in the first hour, so you just leaving it as this, right? Whatever it works out to, as it's a whatever 1,903 or 4, and you just leave it like that, right? And it's okay.
yeah, leave it as the fraction. Yeah. This can't be simplified anymore, right? So it's either the fraction or the decimal. But between the fraction and the decimal, I'm telling you, put the fraction, right? Because it's just a more accurate answer than putting in the decimal. Yeah? Because the decimal would be an
If you
approximate.
had gotten like a value, right, like 99 on 3,
Okay.
you
That
leave it on 99 on 3 or
No, 99 and 3 could be reduced. So you reduce it. This cannot be reduced. You get what I'm trying to say? Yes, no? You understand what I'm saying?
yes.
Okay. Any questions about this? Anybody not guessing this answer? Okay, clearing it off. All right. Goodbye, my son. Well, you don't have to rejoin, choose. You could rejoin though, because you wanted to